Hello my dear students, and today in this class we will discuss about the chapter surface chemistry, and we will see what is mean by this surface chemistry and what is the definition of a surface. Right, surface chemistry mainly deals about the surface phenomena. Surface phenomena means see the process which are occurring only on the surface, right, not inside the bulb, which are taking place only on the surface. See, not inside the bulb. That is called as what here? Surface chemistry. And here first we will discuss about what is the definition of surface here. And surface can be defined as it is the topmost layer on the bulk material. We can take any bulk material. See, up to the 100 nanometer length, that is the layer should be which is ranging from, that is topmost layer which is ranging only 100 nanometer length. That layer is called as what? Surface. Means, so we are not taking a complete depth area, we are taking only, that is only 100 nanometer area from the topmost layer. That area is called as what? Surface. And in this chapter we are discussing only about the process which are taking place only on the surface, right? And here there are mainly different type of the process taking place on the surface. One of the most important process is the adsorption. And adsorption is nothing but the definition of the adsorption can be defined as, right? So before going to see the definition of the adsorption, first we will see some examples here. For example, if you pour or if you throw that is any sand powder, right, any sand material, right, any powdered material on the surface of, for example, a duster you are taking. See, if you are throwing some chalk piece powder on the duster, right, so here the chalk piece powder will not enters into the complete duster. So it is staying only on the surface, right? So therefore, see, the process which are taking place are the deposition of any substance only on the surface or accumulation. Deposition can be also called as accumulation. Deposition or accumulation of the any substance only on the surface is called as what? Adsorption. Therefore, the definition is deposition of a substance. See, the deposition of any substance only on the surface, not inside, only on the surface. The deposition of any substance only on the surface is called as what? Adsorption. And here, in case of the adsorption, there are two things are very important. First one we have adsorbate and second one is adsorbent. What is mean by the adsorbate? What is the definition of this adsorbent is? Adsorbate. Adsorbate means, see here, the substance which is undergoing adsorption. The substance which is undergoing what? Adsorption. That substance is called as what? Adsorbate. See, you can see the definition here. For example, see on the nickel, palladium, platinum surfaces. On the nickel, palladium, platinum surfaces, see the hydrogen gas is adsorbing. Hydrogen gas is depositing or accumulating on the surface of what? Nickel, palladium, platinum. Therefore, this hydrogen gas is acting like what? Adsorbate. Because hydrogen gas is depositing on the surface of what? Nickel, palladium, platinum. So, the definition for the adsorbate is, it is very clear, the substance which is accumulating, the substance which is depositing on the surface of another substance. So that is which is undergoing adsorption. Which is undergoing adsorption, that is called as what? Adsorbate. Here which is undergoing adsorption? Hydrogen gas. Because hydrogen gas is depositing on the surface of nickel, palladium, platinum. Therefore hydrogen gas is acting like what? Adsorbate. Means the definition, simple definition is the substance which is undergoing adsorption is called as what? Adsorbate. Next definition we have adsorbent. Adsorbent means, see, on which adsorption taking place. See, here you see that nickel, palladium, platinum. On the metals like nickel, palladium, platinum, adsorption is taking place. What process is taking place? Adsorption. Nickel, palladium, platinum is acting like what? Adsorbent. Means, say on which the adsorption is taking place, on which the process adsorption is taking place, that is called as what? Adsorbent. Once again I am repeating the definition. Adsorbate means the substance which is adsorbing on any other substance is called as adsorbate. The substance on which adsorption taking place is called as what? Adsorbent. And here adsorbate may be in the gaseous state, liquid state, solid. But adsorbent is always in the liquid and solid state, but not in the gaseous state. So these are the three definitions we have: adsorption, adsorbate, adsorbent. And examples for the adsorption I am taking: activated charcoal adsorbs gases like chlorine and sulfur dioxide. And here chlorine and sulfur dioxide acting like adsorbate, and activated charcoal acting like what? Adsorbent. And similarly, we have nickel, palladium, platinum. Nickel, palladium, platinum is adsorbent because on which adsorption taking place, and hydrogen gas is adsorbing on the surface of nickel, palladium, platinum. Therefore, they are what? Adsorbate. And these are the two examples we are taking. And now we have mechanism of adsorption. Actually, how the adsorption process taking place. Right? See, the adsorption process mainly in case of the adsorption, we have to remember these two are very important: adsorbate and adsorbent. Right? See, in case of the adsorbate, for example, you take any bulk material. For example, activated charcoal you are taking. Activated charcoal is one of the bulk material. Here, some particles are there. Charcoal particles are there inside the bulk. Inside the bulk, some charcoal particles are there. I am showing. This is just to take like any material. Like you can take nickel, palladium, platinum. These are acting like adsorbent, or you can take activated charcoal. And in this, all the particles are there inside. These all particles are not having same forces. Means here, the forces between these particles are not equal. Therefore, we are calling these are unbalanced residual forces. Unbalanced what? Residual forces. See, similarly, the adsorbate particles, see, they are coming near to the adsorbent. During the adsorption, what happens? The adsorbate particles coming near to the adsorbent. See, in between these two, some forces are developing. Some forces are developing. And here, due to these forces, see what happens is, there is always decrease in the, that is enthalpy taking place. Because when this adsorbate particle comes near to the adsorbent, when the adsorbate particles are come near to the adsorbent, then what happens is, see, some unbalanced residual forces will develop. See, which force are developing when these particles are coming to the adsorbent? Unbalanced residual forces. Due to these unbalanced residual forces, the temperature will be decreased. The decrease in the temperature, that is nothing but enthalpy of adsorption decreases. Therefore, enthalpy value becomes what? Negative. And similarly, when these particles are depositing on the surface of adsorbent, nothing but adsorbate particle when the depositing on the surface of adsorbent, they are completely systematically depositing on this. Therefore, disorderness will be decreased. See, you know that in case of the entropy, entropy is nothing but it is a measure of disorderness. As the disorderness increases, entropy value increases. But here, when the particles are systematically depositing on the surface of adsorbent, the completely disorderness will be disturbed. Therefore, entropy value also decreases. Delta S negative means entropy value, that is, as the disorderness decreases, entropy denoted with the negative. Similarly, there is always decrease in the temperature, therefore change in enthalpy value also decreases, that is denoting with the negative. When both the values are becomes negative, you know the formula for the change in Gibbs free energy. What is the formula for the change in Gibbs free energy? We are taking delta G. Delta G is equal to what is the formula? Delta H minus T delta H. Change in the Gibbs free energy, delta G is equal to delta H minus T delta S. See, both values are becomes negative, then the delta G value also becomes what? Negative. Therefore, when the delta G value becomes negative, this process is called as what? Spontaneous process. And here you remember how the process is taking place is, see that first the molecules which are present in the adsorbent, they are completely not showing equal forces. When the particles, these adsorbent particles are comes to the near to the adsorbent, then there is a unbalanced residual forces will be developed. So they are attracting this. So when the unbalanced residual forces will be developed, there is always a decrease in the temperature. The decrease in the temperature, that is denoted with the decrease in enthalpy, that is delta H is equal to what? Negative. When the particles are depositing on this, when these particles are depositing on this, disorderness will be decreased. See, as the disorderness will be decreased, entropy value become, change in entropy value become negative. When these two values are become negative, delta G value also become what? Negative. By the formula, delta G is equal to what? Delta H minus T delta S. When the delta H becomes negative, Therefore, this mechanism of adsorption or the adsorption process is always what process? Spontaneous process. So this is what the mechanism of the adsorption. And now we have one more process. So that is, still now we have discussed about the adsorption only. In case of adsorption, we have discussed about the adsorbate, adsorbent, and next examples and the mechanism of adsorption. And now we are taking one more process, that is absorption, and it is adsorption, AD. And now I am taking absorption, AB. Absorption means, for example, if you, that is, when you put the sponge in the water, generally sponge, when you dip in the water, then what happens? The sponge will immediately attract the water, right? Immediately the water will enter into the sponge. Water is completely entering into the sponge. Therefore, this process this is one of the example for the absorption. Absorption means, we are defining the definition. Gas or liquid, or solid molecule distributing uniformly in the solid, right? Either solid or gas or liquid molecule, they are completely depositing or completely distributing inside, not on the surface. Insidely distributing. Insidely when they are distributing, that process is called as what? Absorption. The difference between adsorption and absorption is, adsorption taking place only on the surface, but absorption taking place inside the bulk. The molecule will enter inside the bulk, that is completely they are entering inside. That process is called as what? Absorption. And we have one more definition, absorption. Sometimes adsorption, absorption, both will taking place simultaneously. At a time, adsorption taking place, absorption taking place. So then it is called as what? Sorption. Sorption means adsorption and absorption takes place what? Simultaneously. And next we have definition, desorption. Desorption means, see here one in the example, for example, you are depositing some particles on the surface of, this is we are taking as adsorbent. We are taking it as an adsorbent, and this is what? Adsorbate. We are taking what? Adsorbate. It is adsorbate which are depositing on the adsorbent. For example, if you remove these adsorbate particles, if you remove this adsorbate particle on the surface of what? Adsorbent. See, removal of adsorbate particle from the surface of adsorbent. Removal of adsorbate particles from the surface of what? Adsorbent. That process is called as what? Desorption. Desorption means removal of adsorbed particle from the surface of what? Adsorbent. This process is called as what? Desorption. And these are the some more definition. And now we will see there are two types of the adsorption. Means here we are taking types of the adsorption. Adsorption is of mainly two types. See how they are classified is based on the forces. Based on the forces attracting between, or the force of interaction. Force of the interaction between adsorbate and adsorbent. There are two types of the adsorption we are taking. The two types of the adsorption are physical adsorption and chemical adsorption. Physical adsorption and what? Chemical adsorption. Based on what they are classified? The force of interaction between adsorbate and adsorbent. Based on this, there are two types of the adsorption we have: physical adsorption and chemical adsorption. See, first we will discuss about the physical adsorption. What is physical adsorption? For example, in between adsorbate and adsorbent, if in between adsorbate and adsorbent, there is a weak van der Waals forces. Weak forces are acting. Weak forces are present between the adsorbate and adsorbent. So that type of the adsorption is called as what? That is, we are calling it that is physical adsorption. That is weak van der Waals forces. If they are acting between adsorbate and adsorbent, that type of adsorption is called as physical adsorption. For example, if strong chemical bonds are present between adsorbent and adsorbent, strong chemical bonds or strong chemical forces are present between adsorbate and adsorbent, that type of the adsorption is called as what? Chemical adsorption. Means here which forces are acting? Van der Waals forces between adsorbate and adsorbent. Here what forces are acting? Chemical forces. And next, in case of this one, the delta H value, enthalpy, that is enthalpy of adsorption. Here it is weak force are acting between adsorbate and adsorbent. Therefore, enthalpy of adsorption also very low. Therefore, the enthalpy of adsorption value is 20 to 40 kilojoule per mole. And in case of chemical adsorption, strong bonds are present or strong chemical force are acting between these two, therefore enthalpy of adsorption is high, that is 80 to 240 kilojoule per mole. This is the second difference. Third one, it is reversible. Why? Because you can deposit easily adsorbate particle on the surface of what? Adsorbate, right? So forward direction, that is easily you can deposit. And desorption also taking place easily. Therefore, both processes are taking place. Adsorption, desorption, it is taking place in the both direction. Therefore, it is a what process? Reversible. And it is a irreversible. Once the adsorbate depositing on the surface of adsorbent, they are forming which bond? Strong chemical bond. Therefore, we cannot easily remove. Therefore, it is a what process? Irreversible. It is taking place in the both direction. But it is taking place in how many direction? One direction. And next one, here weak van der Waals force are attracting, therefore low temperatures are favorable. What temperatures are favorable? Very low temperatures are favorable for the physical adsorption. Here high chemical bonds or the strong chemical bonds are present between the adsorbate and adsorbent. Therefore high temperatures are required for the chemical adsorption. Next here, as the temperature increases, so once you increase the temperature during this process, the physical adsorption will be decreased. What will be decreased? Physical adsorption decreases as the temperature increases. But as the temperature increases, chemical adsorption increases. As the temperature increases, chemical adsorption increases. This is because of only weak van der Waals force are there here. Therefore, as the temperature increases, the bonds become weak. Therefore, it decreases with increase in temperature. Here, chemical bonds are there. Therefore, as the temperature increases, the chemical adsorption increases. Here low temperatures are required, high temperatures are required. And now it is not specific, means it taking place in all the surfaces. Therefore it is not specific. It takes place only some surface. Specifically it is taking place. Therefore this is called as what? Specific in nature. And it is completely multi-layer. For example, first one layer is adsorbed. Next it enters into the another layer. After that it enters. First layer is adsorbed, it goes to the second layer. Second layer adsorbed, goes to third layer. Therefore it is a multi-layered, but it taking place only on the only one layer. Therefore it is called as what? Unilayered. It is unilayered and it is multi-layered. An example for this adsorption taking hydrogen gas on charcoal. Hydrogen gas on charcoal is an example for physical adsorption. Same hydrogen gas on the nickel. Nickel metal is an example for what? Chemical adsorption. So these are the differences between physical adsorption and chemical adsorption. Based on the forces of interaction between adsorbate and adsorbent, there are two types of the that is adsorption we are taking, physical adsorption and chemical adsorption. In case of physical adsorption, what forces are acting between adsorbate and adsorbent? Van der Waals forces are there. And in case of the chemical adsorption, what forces are acting between adsorbate and adsorbent? Strong chemical forces are acting between adsorbate and adsorbent. Based on the that is force of interaction between adsorbate and adsorbent, mainly they are classified into two types, physical adsorption and chemical adsorption.